So let's move on IGU parts. This is most important because each part will have a lot of effect towards IGU performance, whatever we talked about applications benefits. So these parts, each part will do a better job as a nature. It will deliver for us a performance. So let us look at it, what are the IGU parts. So having said that, there are two pans, or there are more pans also together. You can hermetically sealed primary and secondary silicon, that by you can separate it by aluminum channel. Okay, so this is the construction. It's a typical construction of IGU, insulated glazing unit. So let us look at it as a face, like from the exterior portion. The first pane, you are seeing the glass. So the glass can be one of the best element in terms of DGU, which occupies a lot of space. It delivers a lot of performance, like light comes in, goes, reflect, internal reflection, outside reflections, what U value selections, what color of your facade has to be. So the glass occupies a lot of space. It's a it's a prime function of the glass. The prime parts of IG is, it's a glass. The next is the butyl, which is ensure water vapor tightness, which will not allow any water to seepage inside the IG unit, or if any moisture at the time of glazing, if any water moisture would have been there, okay, it will not allow to penetrate into the secondary sealant. Thereby, you'll have a loss of insulation problems. It will come. So that will be, it will give you a ensure water tightness. It prevent vapor tightness. It allows structurally strengthable, and this butyl will help us like in the deflection, like high wind load. So the glass may tends to leave, like deflect during those deflection periods. So this butyl will help enable us, enable glass to tends to move from like one original position to 2 mm, 3 mm with help of butyl. So that's the stuff it can have from butyl. And next is a secondary silicon, protect basically from exterior conditions like water vapor or chemical vapor or rainy season, what are our sun exposure, what are the messy outside is there. So in order to avoid, to protect to water inside, so the secondary sealant structurally will give a structural strength to the IGU, as well as it prevent this abnormal conditions like water, humid, hot gases or fumes or chemical agents need not to penetrate inside the DGU. So that secondary silicon will prevent those abnormalities. Let us look at it. Next is a spacer, and the spacer is a weight in nature is very, it's aluminum spacer. It is a hollow spacer. It won't weigh much when compared to the glass, but it has a lot of quality. Basically, it gives a mechanical strength. Basically, it separates two glass. It will give a space of a two pane, which should not sagging effect. So it will help us to separate the glass pane in a proper manner. So we'll have to fill this desiccant. So the desiccant perform impact on the condensation effect. If the IGU need to protect the condensation, so that your desiccant has to be a proper one. So the desiccant would absorb the water moisture from which is present in the DGU, or if anything comes inside, it will absorb the water moisture or hydrocarbons. It should not absorb any thermal performance gases like argon gas, like inert gas, which we talked about, argon, xenon, krypton. It should not absorb it. So that desiccant should it's widely used in all of the facade. All of the IGU insulated glazing unit. Again, one more thing, wherever the separated, the dry air, either you can space between the two glasses, either you can keep it as a vacuum, or you can keep it as a dry air, or you can fill it with the argon gas or xenon and krypton, whichever form you want to use it as a filled in. You can decide based on the performance what you wanted. You can go ahead, we can select it. So each components here, which is widely highly helpful for in terms of serving this for us to be happy inside the building. So these parts are widely highly helpful for making IGU grand success. Next, move on the technical fundamentals of IGU, so which we discuss about it. So IGU, it's nothing but there are two or more panels, glass, separated by a mechanical aluminum channel, which is hermetically sealed with help of a primary and secondary silicon. So this is how IGU construction which you talked about. IG parts like air might be a dry air or be a vacuum or inert gas, argon, xenon, krypton, which we discussed about. There is an overview of IGU. The first is, the most important is glass cutting and grinding. It's a it's a pre-processing, what we call this. In the IGU process, it's a pre-processing. So you'll have to draw the glass from the warehouse. You have to keep it on the loading table. Order size you want to do it, so you have to optimize, and thereby you have to cut it and snap it, and you have to store it and grind it. The grinding is most important, because if any shell form or in the grinding is not proper, the glass tends to break at the tempering section. So in order to avoid, as need not to be serve only tempering area, it serves people like to handle it from one place to other place. So after cutting, the grinding, it helps us for the workers to handle the glass in a safe manner. So basically we are eliminating the sharpness from the edges. So we are erasing, or you can polish, or it can be done like a single edger, double edger, or seaming machine. There are three types of machines available to grind the surface. And washing and tempering, yes, washing is most important. Not only washing, each process in IG is very, very, very critical. If you do any mistake, it will be replicate at the end of the IGU. So we'll have to be very careful in terms of all the process. So washing, like again, if you use a Lowy glass processing, water level, like it should be the pH of 6 to 8 pH, and should be less than 10 microsiemens. And temperature, and most of the processor should not follow the temperature on the water tank. So temperature should be more than 35 degree. It solves the growth of bacteria, or the hot water, basically it serves a lot of cleaning effect. But most of time people are using the cold water, which will not help us in the long run. So the temperature also, it's widely used. It has to be used more than 35 degrees centigrade. It has to be used at the time of washing machine. And drying, it's most important. If any water droplet present on the Lowy or the normal core glasses, if you fed into the furnace, it will break. And so again, suppose if it is not breaking, so if it is a Lowy glass or any other like ceramic glass, anything is there, the coating burnt because of the water droplet were present on the coated surface. It will have an effect of after tempering. So washing is most precision process in terms of IGU, because thereby it will allow you to enable you to see, and you have to thorough quality check before taking to the tempering. So tempering, as you all know about it, it's basically we are increasing the strength of the glass from annealed glass to tempered glass, which is 4 to 5 times than the strength. So it's a heating process. So we have talked about the pre-processing and tempering. So let's move on to the IG process. So IG process, it's a frame manufacturing is the first process. Basically, it's nothing but the aluminum channel comes under running meters. So based on this your size, you will have to bend it. Either you have to cut or you have to bend it. So there are two ways. If you want to cut it, then you'll have to use a corner key to join it. If you want to bend it, even only 2 bends are required, from the top and bottom. So it can be used. Only another bend can be, one more corner can be used. And after bending or before bending, you can do a molecular sieve. It can be filled on the hollow aluminum channel. That's the process. Either you can do it manually or you can do it on the automatic machines, robotic machines. So nowadays people are robotic machines usually, but we would always advise you to use robotic or automatic machines. So it helps us, because if you use manually filled with the desiccant, so whoever fills it, so if he is not using the gloves, or the gloves is got dirty, or it has a moisture, so that moisture will absorb by the desiccant, so you'll have a less durability of IGU. So you'll have to protect that one, because the desiccant has a lot of value towards less condensation, viewability, transparency, a lot of things. So you'll have to be very careful. So we would advise you to use automatic filling machine for molecular sieve and butyl applications. Once it is filled, so based on the shape what you required of the project, then you have to take it to the next machine. It calls a butyl extrusion metal. Basically, there are two pumps, there are two nozzles are there, which is dispensing the butyl, which is primary silicon, through the two nozzles from one side to other side. When you take out this, it will be in a uniform form. You have to take it and gently you have to keep it on the glass pan. So we'll have to use very precautions here, because our thumb mark, like fingerprint mark, should not be impressed on this primary silicon, because it will be see-through when the time of pressing. So we'll be able to understand the fingerprints will be there after pressing it. Basically, a finished good, you can see that. So in order to prevent that, you have to use gloves, or better not to touch with your fingers, gentle holding. So that's expertise. Based on the experience, you'll have a more experience. You can get expertise on this. Next is process is frame positioning, which once the glass is washed and once the bending, molecular sieve filling and butyl application is done, and carefully you have to keep it on the glass, which is first glass which washed and comes stands for ready for adjoining with this frame. So one glass has come, then we'll have to keep this filled desiccant filled aluminum frame on the glass. Carefully you have to keep it, and there will be another glass will come. Then there will be a next is brushing and basically pressing. 6 bar will be applied on this time of pressing. During the pressing, it will be automatically, you can have, suppose if you want to use any inert gases like argon, xenon, krypton, you can use it, you can fill it with a at the time of filling, it can be automatically can be done. So gas filling as well. Next is sealant extrusion. Most of the people are using manually, but we would advise you to go for the robotic sealant, so that you don't have a sagging effect. Because one more thing, it has to be done, the secondary silicon operation should be done on the vertical in nature rather than doing on the horizontal, because horizontal, based on the self weight of the glass, the one glass you kept and another glass you kept it, based on the length width is higher than the 2 meter, 2.5 meters, the center portion will have to have a sagging effect if you do on the horizontal glazing. Otherwise, like if you use it on the vertical glazing, you don't expect that sagging effect what comes, which plays at the time of secondary silicon application. So we'll have to keep in mind, so either it will be automatic, which is robotic, or should be a vertical application of secondary silicon. So the secondary silicon, the main function of a secondary silicon, the moment you apply, within 3 to 4 hours you can dispatch the glass, because it has the curing rate is very faster when compared to the primary silicon. Whereas primary silicon will take more than 36 or 48 hours to cure completely. Whereas secondary silicon, its immediate effect, even within an hour you can shift it from one place to other place, but we would advise to dispatch probably after 4 hours. It would be ideal for you to dispatch, because your silicon would completely curing. Not only the outer layer, the inner layer also would get cured within a 4 hour span of time. So it can be dispatched after curing. It can be dispatched in a proper manner. And main Igu process. So we discussed about the pre-processing, like cutting, grinding, washing, tempering, and let's move on to the Igu process. The Igu process is mainly frame fabrications. It's the most important process. And having said that, desiccant filling. Once it desiccant filled, so wherever the puncture you are done, so those area has to be carefully, we have to use butyl to plug that hole. Please do not leave it void, or please do not open, because the desiccant have been inside, that air vent, there will be a possibility of getting the moisture through this vent. So it has to be, once it is hole is done, once you filling the desiccant, after that you have to take back and fill with this butyl, which is basically primary silicon, to plug it, and you can go for a next operation, which means frame positioning of the frames on the glass. So this is the next step for IG process, which means primary silicon, which will be taken to the primary extruder machine, which will be a part of IG process. Though it will be, it's not offline product, you can say it's another machine. It's not joined along with the IG process. It will be another machines like accessories machines, kind of like this, where you can do a primary extrusion through this butyl extrusion machine, and carefully we have to press it. After done it, we have to pressing is taking place. During the pressing, we can, if you want to use a gas filled, you can have a gas filling can be done on this, and after that robotic sealing, vertical glazing can be done with help of secondary silicon. So this is the main IGU process. So you'll have to keep in mind the pre-processing and tempering is most important. After that, this is the main concept. You'll have to understand the main IGU process. So frame positioning, frame fabrication, desiccant filling, primary extrusion on the aluminum channel, and pressing with the gas filling, and secondary applications, which is secondary silicon applications.